Okay, we're going to be talking about 13.1 DNA and RNA. We know about DNA, now we have this new guy called RNA. Here's a picture that's in your book. I want you to think about, in this analogy, if your master plan here is your DNA, okay, if your master plan is your DNA, that is all the instructions. What has to happen is those instructions have to be copied and then sent out to the people doing the work. So here we have copies coming out. These are going to be looking like your RNA, all right, and more specifically, it's the big plan. These are the pieces, and then this step from DNA to RNA is going to be called transcription. Okay, remember that transcription? It's got the word scribe in it, which is to write. Okay, and we are rewriting the DNA as RNA. Here's a picture from your book that shows you a process of DNA making RNA. I want to show you a couple of differences in this picture. First, you've got a difference here in strandedness. DNA is 2, RNA is only 1 strand. And then I want you to look here. DNA has thymine where RNA has uracil. And wherever there be a thymine, there's going to be a uracil in the RNA. And also, to make RNA, we do not use DNA polymerase, we use RNA polymerase. So those are differences. RNA is single-stranded, RNA has uracil, not thymine, and RNA strands are made by RNA polymerase. This image here shows you the 3 different types of RNA. First, you have your messenger RNA or your mRNA. You have your ribosomal, okay, this is your rRNA, excuse me. And then you have your transfer or your tRNA. All right. The one we're going to be really concerned with is this mRNA, because that one has the code for the protein. However, these two are also important because they are very important steps in translation. This is that chicken and the egg thing. This mRNA is needed to make proteins. This ribosomal RNA is also needed to make proteins, and this tRNA is needed to make proteins. But here are proteins here. So how did this all come to be if they're needed to make themselves? So this is our chicken and egg thing. We don't know. So our 3 types are mRNA. That's what is the code of information, or M stands for messenger, so it has the message. rRNA, that's what makes up the ribosome. And then the tRNA, or the transfer RNA, it transfers the amino acids to the mRNA code. This word amino acids, if you're not quite sure on that, we'll get to that when we get to translation. So this last one here, how does the cell make RNA? This is the process of transcription. Again, it's that scribing. So the DNA has to unwind. That's our helicase. A promoter is going to bind to the TATA box, a TAAA, on the DNA. Then RNA polymerase is going to come in. It's going to copy a single strand of the DNA. And remember, anywhere on the DNA where there's adenine, uracil is going to go on the RNA. And so that is the process of transcription. We go from DNA to a single cell of RNA, or a single strand.